First of all, let me say good morning to all and thank the CEHI. We had a meeting sometime last week with the Minister, Mr. Fletcher, and CEHI made that announcement about the Symposium. I think it was a great idea. I think it's the beginning of the kind of cooperation that we need, and has to continue, because the issue of water, as I always say, has never been taken serious, right? And it's still not taken serious in this country. As we have symptoms or resemblance of a drought, people seem to be worried. But as we have 2 days of rain, or say another 5 days of rain, people will not be worried any longer. And that's the nature of our people. And how do we change it? That's the biggest question. Today I will try and give you some kind of update. As you know, to give a status of fresh water is a very challenging thing because there's so much research that has to be done. So we try to approach it from a very simplistic standpoint. And hopefully, what I'll present to you today will give you an idea of the status of water, fresh water in solution. This is basically the table of content. There may be some adjustments. Okay, I think it's important that if we talk about fresh water, for people to understand the origin of water. We see waters in rivers, we see waters in all kinds of bodies, and we wonder. But this is where the process actually starts. It's very, very important to understand the water cycle. Basically, the water cycle is about the continuous movement of water, all right, above, below, and under the surface, or below the surface of the earth. And it actually starts with the process of evaporation, all right, where you have large water bodies, picking up heat energy, vaporization, and that moves up to the atmosphere. You have condensation taking place, cloud formation, and you have rainfall in the form of the precipitation, which can be rainfall. In the temperate countries, it will be snowfall. You have drizzle, and all these various forms. So what really happens is that under the hydraulic cycle, if all these processes, evaporation, condensation is missing there, precipitation, when that rain falls now, you have several alternatives for that rainfall. Either rainfall goes directly into the stream, but obviously one of the most important components is the runoff. All right, and why it is important, I want to just strike on a note that Ms. Cruzel was referring to. That runoff, if it does not get into a channel, it runs along the surface and it becomes a source of non-source point pollution. All right, it can pick up contaminants like fertilizers, pesticides, and all these various things, and then enter the water, and it becomes a problem. I just wanted to show that link there immediately. And in the cycle, runoff is considered to be one of the most important processes. All right, very, very important. It can be both good and bad. But obviously, the most important process is evaporation. Now, what happens in that process is that water molecules are able to move in and out in the atmosphere, all right? And this actually is driven by the processes, like I said, evaporation, condensation, but a very important process is missing there, or it's at the site, infiltration. This is what actually gets water in within the soil surface, beneath the soil surface. And through that process, you have a deeper process taking place, percolation, and that's where water gets to the subsurface, to your groundwater. Now, some of that groundwater would flow laterally and come out as springs, but some goes deeper and feeds your aquifers, and you have groundwater, which you have not been exploiting. We're doing some work on that. So I think it's important that we understand the hydraulic cycle, or the water cycle, is everything you need to know about water. If you don't have a hydraulic cycle, some people try to mimic it or manipulate it by doing different things with vegetation, but that again has been a failure to some extent. All right, so in our situation in St. Lucia, that is why we need the forest, because of our topography, our geology. So if we have open lands without forest cover, that means most of our steep slopes would be exposed, and what we would have is a lot of water rushing down as runoff into the streams, into the sea, and our base flow would not be rejuvenated, and as such our groundwater would be affected. So I think it was important, just as a first slide, to get people to understand. And there's a lot of work on, a lot of information on hydraulic cycle on the internet. So if you are interested, you can read it up, and it's a very important thing to know, because I think it's important for kids to know also. Next slide, please. In terms of some of the current situations, rainfall again is something that's very important, and the rainfall varies from the coastal area to the central rainforest area. You have 1,450 millimeters to 3,450 millimeters, and that is in Edmond Forest. And that is important because what it says is that on the coastal area, you have a very limited rainfall pattern, and that can impact, and hence the reason why places like Moshi and Social and these places may have serious problems for water, unless you have forest that feeds internally to provide water for these areas. Base flow, which is something that most of us are not interested in, but it's very important, because even with the present drought, we are getting readings of base flow measurements that are showing a decline in the amount of water in the river. And I will get to that also. And what we are seeing is that in the northern section to the southern section, you have 75 liters per second and 1,050 liters per second for most of our rivers in north or the south. That information is coming from documents that are presented or studied, all right? So it's not information just we're picking up. It's been recorded and documented. Okay, in St. Lucia, we have 47 watersheds. We have tried to, this is not a St. Lucia diagram, right? The one to my closest to me. This is something that we took from some booklet, but it's important that maybe sometime down we have something that can show our watershed. But what we're trying to depict there, if you look at the Roseau watershed, and we see this is a larger scale of it. All right, what you have is that the watershed has three major components. You have the upper reaches, the medium or middle reaches, and the lower reaches. And what's happening there is that in your upper reaches you have forests, and you can see the various tributaries or water pathways that come in to lead to the main river. We may call it the Roseau River now. All right? And what happens is that in your upper reaches, you have full-fledged protections. You have forests. You have a stratified forest. But as you come to the middle, you have development taking place. You have structures. All right? You may even have animal rain in that area. All right? Now, all of these are very, how would I put it? This makes it very complicated in management of a watershed. All right? And then in the lower reaches, you have development, you have roads, all right, and you have a lot of pollution that could go into the water. Now what we are saying is that in situations like that, where fresh water is our main source of drinking water, domestic water supply, we need to manage these watersheds in a very integrated fashion. And by integration, I mean that all the players that are involved in the watershed, those that reside there for industrial and also for charcoal or for forestry, need to come together and develop guiding principles, best practices, so whatever water comes out from the watershed will be of a high quality, and also there will be a consistent supply of water. In St. Lucia, we have not developed any watershed management plans to date. We're in the process of looking at guidelines for a World Bank project, and hopefully when that comes on stream, we would have some management plans. But it's very important to understand that most of our watersheds, that is what exists. The Castries Basin, that's the entire watershed. That might be the most complex and useless watershed, if I can say that, because you literally cannot harness any water for domestic purposes in that, all right? Look at the Castries River, the status of the Castries River, all right? We are with so many plans have been developed for that particular area, and look at the state of it right now. To the extent that if you have too much rainfall, you actually get flooding in some areas there, all right? And that is because of the lack of garbage disposal and all these various activities that we cannot actually manage in the watershed. So basically, that's just to give you an idea that we have 47 watersheds. And the next slide will show you some of the major watersheds we have in St. Lucia that are under management, and that was derived from work done by Professor Morgan and his associate. If you look at the stream flow, dry season stream flow, you can see the highest stream flow is in the Roseau, Chumase, and again I think that is very understandable. That is the areas where you have majority of your forest existing. All right. If you go down to the lower sections, Fordor and Dore and Canals, although you may have some forest in these areas, but I think the Chumase and Roseau catchments are more densely forested, and hence the reason why you have a higher stream flow. Now, you may want to understand or may want to link forests and stream flow. Basically, in a forested area, you have various stratas. So as rain falls, all right, the rain will not reach that surface as compared to an open area where you have two stratas alone. It's going to take some time. You're going to have what they call through fall. You have a thick little layer which acts as a sponge. And it's going to take time now for that water to actually run off. Whereas in another area, you're going to get immediate runoff. Now, in that forested area, you have a lot of deep percolation or movement of the water deep within, which now could go on to base for storage, and there you have a base flow. So in a situation like that, you have a greater amount of stream flow taking place as against another area. Your immediate stream flow in another area would be the runoff. But if you do that measurement soon after, it will be declining. All right, so immediately after rainfall, in an open area, you have a stream flow that is high because you have a lot of runoff going into that stream. Do that stream flow measurement 2 days after, it will decline because the base flow is not there to support it. Compared to a forested area, you're going to be a constant base flow over the time period. And that's basically because of the impact of the forest. Now, to be honest with you, I put that there just to give you an example of the current situation, but we do not have enough data on stream flow. So do the regression may show some kind of thing, but absolutely does not have enough data. But I think it is relevant for you to understand that. For example, in the Deglo area, where the rainfall, and before I go on, the rainfall in Deglo compared to the drought period 2009 to 10 is not much of a vast difference. However, the stream flow is different, and that's where the issue of Thomas comes in. In 2010, we had our forest standing. Our forest was resilient. All right? That is before Thomas came. However, in 2012, 2013, our forest is standing, but it's not resilient because it has been degraded. So the impact the forest would have had in 2010 compared to now is totally different. You have more openings in the forest. All right? Your stream flow or your baseline in the forest will be different. All right? Your storage capacity is also different. All right? So there's a total difference, and I think that's what we need to understand. And I was speaking to Hosanna before coming up here, and we hear on the radio about we have a drought. We have not reached a drought yet, and we intend to clear that up. All right? We have information that is telling us we are moving into a drought. But for you to declare a drought, and there are different kinds of drought, and the drought we want to declare at some point, if it does exist, is what we call hydraulic drought. And for you to do that, you must have your base flow, which would be below a certain average for how many months. Even the water that Wasco takes in would have to be reduced over a certain period of time for how many months? Because Wasco must be getting the same amount of water they were getting in 2010. We don't know. All right? We don't know. So unless that amount of water has declined over a certain period of time, coupled with the rainfall and the stream flow, all right, and other factors, then we can declare. All right? But all of us seem to be forgetting that we had Thomas, and that has changed the structure of the forest. And hence the reason we are seeing these declines. All right? Had our forest been the same in 2010, we may not have been seeing that situation. And that is something that we need to try to understand. The science of that is very, very important. All right? So I put up that just to show you that we are taking base flow measurements at some key rivers. However, the data is not enough, but still this one shows there's a rapid decline because the regression here, we have two axes. We have the rainfall here and the stream flow on the other side, and that's just the time phase. And it's showing a negative, a minus 4 point something. All right, so you see a sharper decline. The rainfall is not declining that much. You have a minus 0 point something. Next, please. Same thing with Mabuya Valley. We only have about 3 points of data. And notice the rainfall. Same kind of thing, about minus 2. Next. Canals. So basically, all three diagrams show the same trend in the decline in stream flow, right, over time. But like I was saying, that the data is not sufficient to actually make some sensible thing. But basically, that's the trend that's going on. In terms of our major water supply sources, our surface water, like I said, surface water is our main source of water. The estimated 7 billion gallons of water per year, and that information is coming from Wasco, and that is after runoff. Again, Ms. Cruzel did make mention of springs. Wasco does harness water from 2 spring sources in Supra area. All right? The other options that we have are the groundwater options. I will explain to you. We're doing some work on that presently under our student-funded project. Potable water is our prime source. Wasco manages the John Compton Dam and approximately 28 intakes. Now, we had the privilege of going to 30-something intakes, if I can recall, because normally, or as agency responsible for water resources management, we have to do an assessment of every single company or person abstracting water on the island. So we have to go to every intake Wasco had around the island to do an assessment, all right, to verify the amount of water they're taking out and to determine whether Wasco can remove that amount of water from each of the intakes. All right, that's important. Climate change, I think most of us are familiar with climate change, and what we are saying is that, and I wrote something that upset people there. I just wanted to share it with you guys. Are we really feeling the effects of climate change as of 2009, 2010? Can you recall in January 2010, we had some serious flooding. When the rains came, that took us by storm. We were surprised. Is that the effect of climate change? I can't answer that question. Yeah, we need to study, but these are the kind of phenomena, these are the kinds of things that are happening, and we seem to ignore it after 2 or 3 years and we move on. 2009, 2010, we had a drought in the entire country. Driving down Canaries every weekend, you would just see fires, and you're wondering what is happening, you know? Look, this year, we had Thomas, most severe hurricane in how many years, you know? We had the devastation of the forest, an aerial trip to about almost 2,000 landslides, ranging from 5 miles to half a mile, all right? Areas were cut 90 degrees, you can actually see the rock, and you know, what is happening? These are the kind of things we have to ask ourselves. We have to be sensitive to them. So when you leave here today after this symposium, I mean, you don't meet your friend and say, boy, this thing is very interesting. You need to sit down and speak about these things, how we can push that as civil society, all right, to make governments or government be more responsible and responsive to things like that. You know, how can we support a CEHI or the Water Resource Agency and Wasco? These are the kind of things we have to think of, you know. I mean, I feel good sitting there and talking to you, passing information. By the end of it, what happens? I can't feel good after that because you all just move on and you still leave me and my staff or say to fight the same battle all the time. So where we going? We're going nowhere. So I'm hoping that today, the method that people are here is to pick up, and like Ms. Karen said, it's awareness. But awareness has another side to it, sensitization. Because awareness is just about knowing, you know. Sensitization is when you act, you take action. Right? You meet with people in your communities and you put them together and you discuss issues. And we say, let us try and do this and that. And that's what I want to start seeing. I only have a year and a half in this business, you know. When I leave here as an official of government, I have to find another forum to talk. So I hope that by talking to you today, you now get sensitized that you can do something for you that have 15 years in government again and not just come to these things and feel comfortable. All right, next slide. Coming to the springs, research on springs, again, Ms. Cruzel did make mention of it, and that's part of the extensive work that Dr. Morgan did. All right, and it's quite legible in terms of the green areas, suitable water for drinking, yellow areas, low levels of contamination, and the red area, that's supposed to be red.
The gray area.
All right, that's supposed to be red. You have an error here. All right, apologies for that. All right, the red areas are highly contaminated. So I think there are about 35 areas there. And out of that, only 9 of them are suitable for accessing water. And again, like Ms. Cruz was saying, people access these things, these points of water in times of drought or in times of disaster. So we don't know what our people taking into the system when we drink water. But that's very important, you know, for us to look at these things and how we can deal with that on a more serious basis. And that kind of study, we need to continue it because there may be more than what we have on the board there, and we need to look at it greater isolation so we can deal with these issues. All right. In terms of initiatives, the agency is actually, we have just sent to the Australian government for approval of a component which is the Wastewater Inventory Initiative. And we're hoping that we get approval for the hiring of a consultant to undertake that study for us, all right? And basically at the end of the study, we want to identify and locate areas for waste discharge, so then we can actually have a system in place where people can discharge the waste and they can pay a fee for that, all right? And as you can see, the details are very much clear as to what the outcome of the project would be. And that project would actually tie in good with the project that was developed by a group of persons, which was headed by Justin Seeley. And it's also going to be funded by World Bank. It's a wastewater framework policy. All right, so that will actually tie very good with that. Next, please. In terms of groundwater, well, the agency has been doing some studies, again under the Australian project with Dr. Morgan. And I must say that I feel very competent that we have a crew of persons, though a very small crew, that are actually able to go out now and look at sites and conduct tests in terms of using the resistivity method to determine potential areas that are suitable for groundwater exploration. That's been very challenging for them because we have had some long days, because you know when you work with people like Professor Morgan, you're not leaving at 9, leaving at 7, and you come back at 7 in the evening. I mean, there was once 3-4 weeks ago when these guys came in, and Hosanna was part of it. I couldn't even make out the color of the skin because the sunburn out there was so terrible. You've been out there for about 10 hours in the sun wasn't easy. By the end of the day, the technology is something that's going to be owned by Solutions. I mean, just in the process of purchasing our own equipment, that after the project, we're going to have a map showing certain areas, but the unit can continue doing that kind of a work. So if in the future, companies were to come into the government of St. Lucia, there'll be a map showing areas of potential groundwater abstraction. All right? So that would cut down on some of the work that they're doing right now. And also the experience they're gathering is one that is very important. Let's go back. And part of the output so far, like the training is important, but also the report on the Roseau Watershed. There's an extensive report showing the entire investigation has been conducted to date, all right? Yeah. Another area of the project is the enhancement of the hydrometeorological network. Now, that is so important. You know, people will say that we have a lot of data sitting, but when we revisit our data, we have a lot of rainfall data, but rainfall data is not sufficient to do regression analysis and to make predictions as it refers to the water system or the climate situation in this country. And right now we're looking to see how we can increase on our stream flow measurements, all right? Because stream flow is very, very important. As much as we have rainfall data, but stream flow is important. The other thing is that St. Lucia is a very mountainous country and it's a very diverse landscape. And from my research and my readings, it would be best if you could have at least 3 rainfall stations per watershed. I think right now we may have 1, in particular areas we may have 2. So in that way you can actually predict your average rainfall better as against just using data from 1 rainfall station and getting your averages. All right, that would be a better prediction, and you can utilize that for various scenarios. So we're looking to see how we can improve on that, and the project from the Australian funding will do that, but also the World Bank project is another funding source we're looking at. So hopefully the 10 major catchment areas, we're trying to see how we can have about 2 or 3 watershed rainfall stations within that watershed. So we can actually do some more work in that. Sorry. Also, the other thing is that our database, that's another area we're looking at very seriously. Presently, we have WRMA, which is a new database system that is used throughout the region. But we also have high data, which has been there for many, many years. And I think based on speaking to the staff and experience, high data seems to be able to capture a lot more variables, and is essential for us. So we're looking to see how we can improve on that. And our database is not only for use within the agency. With all these projects that are going on right now, people come to us, and that data is becoming very relevant for them to use For example, the drainage work that's going to be done in Deglo and Bexar, the need for rainfall and streamflow data, we are the one that holds that information. So maybe over the next 2 or 3 years, we might be the repository for, or the clearhouse mechanism for hydraulic data in St. Lucia, hopefully. And last but not least, in terms of that slide, the issue of flood and drought mitigation. And I must take the opportunity to let you know that there is a drought and flood committee in St. Lucia. All right, I think they'll be formally launched sometime pretty soon. The TR has been drawn up, and based on what was said by Mr. Poyet in terms of management, there has not been that kind of cohesiveness as yet. So when Mr. Ogis comes out and speaks about the drought index, all right, that is done from a Met front. However, the link with Met and NIMO and water resources and maybe agriculture, that has to be drawn closer, because one of the crucial things for determining hydraulic drought is what they call a crop moisture index, and that is actually lacking in agriculture up to this point in time. So you can see there are a lot of things that are not there, and people assume that we should be able to, but in the absence of information, it's very, you just cannot do it. You can make estimations, guesstimations, but it will not be right from a scientific standpoint. Next slide. Before I go to that slide, also I should mention that presently we do manage a drought monitoring system at Moshi. It's not totally functional, but it should be functional pretty soon. And we have a soil probe up there, we have a rainfall recorder, and we also have a water level recorder up there. When everything is functioning, we'll be able to give some information as to indices for drought in that particular area. Now, some of the challenges in terms of freshwater resource management. Thomas, the biggest challenge. I mean, all of us have driven around the country since Thomas, and even now. One of the most obvious things to us is the amount of silt in the rivers. And that's not only at the lower point, from the very top. All right? We were assuming with RASCO that we should do what we call shallow drilling. Because if you take out that silt, you see water. So literally what has happened, silt has covered the water. But it has covered it to a very serious depth. So there's a potential to get some water there. We don't know, we have to explore. Right? These are the things we hate to do. We hate to do research. We're not a research country, that's the other thing, you know. We sit and wait for people to do things for us, and then we take it on to write. But we must start exploring things. We must start looking at research. And I'm saying that the issue of shallow drilling, there's a lot of history on that. And we need to look at that as a source of water before we go to the groundwater, the deep groundwater. Because the shallow drilling, you have to go about 100 to 300 feet, maybe. Ground drilling, you have to go deeper than that. And the problem with ground drilling, most of our soils are clay. And this is a problem for us. It's very difficult, all right, because that clay base unique. So the challenge of Thomas is that it has left us with a very exposed forest, number one. So that means the resilience of the forest has declined. Many landslides, as you can see, to the extent that many of the springs that we had in the past now become exposed. So they have declined, there are no more springs basically. They have declined to the extent that they become surface water bodies. Okay? Also, given that, we have an issue of the pollution of our waterways. There's even more, it is easy to take place now, and this comes from sedimentation, which is the biggest pollutant. Also the chemicals and the biological pollution. Also, recently, from our research, we have seen a lot of constructions taking place within the river channel. People are starting to construct barriers across the river, so you create a pool of water, and they pump the water to their houses. That's something we are trying to investigate right now. It's happening a lot, and slurry is a key area where it's happening. Unauthorized abstraction of water. This is something we have to grapple with, but one of our deficiencies is our lack of staff. Because what happens is that if you have a river that has a limit as to the amount of water it produces, and you have too much water coming out there, your impact is not only on life, but also on the ecosystem, and that's something we need to look at also. And one of the biggest challenges, again, is the restoration and management of the present forest to bring it back into its natural state as soon as possible. Next steps, preparation of the watershed management plans, through funding of the World Bank, development of a policy, and natural National Wastewater Management Strategy Plan, I spoke about. Continue collaboration with government agencies. This year, World Water Day, the theme is water cooperation. And that is exactly what this third point is talking about. How do we collaborate? How do we work with agencies that work in the sector, all right, without anybody wanting to be a champion at the same time failing, you know? I think it's important to realize that water is such a critical issue right now that we need to come together and work and try and do things in such a way where we understand the responsibilities and the rules and we function so that we can get water to the poor persons, the endangered persons, every voice in this country. And finally, we have a strategic action plan which was completed in March, April 2012, and we are still waiting for that to go to Cabinet for approval. We have started utilizing it, but it's something that we wanted more official so we can use it as a document for funding. So in a nutshell, that's basically what I have to present to you. I hope you have understood and enjoyed it. And like I said, let this not be a session where you just listen. The action after this is very important.